Hello students, today we'll be discussing about 10.03 cracking hydrocarbons from chemistry higher tier. Okay, so in the last topic we have discussed about the fractional distillation, that is how crude oil is separated into different fractions. They have again given a short summary on that. Crude oil is separated into fractions by fractional distillation, but that's not the end of the story. The fractions all need further treatment before they're used. So the crude oil is separated into different fractions, and the fractions must be treated after they're separated. And why they are treated, that's the question here. Okay, so let's see. They might contain some impurities like sulfur compounds. So if they are left in the fuel, they will burn to form a poisonous gas called sulfur dioxide. So the fractions contain sulfur compounds, and when they are applied in a fuel or when they are used as fuel, they can produce a poisonous gas known as sulfur dioxide. So the sulfur compounds must be removed. Okay, and some fractions are separated into single compounds or smaller groups of compounds. For example, gas fraction. We know the first fraction is gas fraction, and the gas fraction is separated into methane, ethane, propane and butane. That means these four compounds remain as gaseous state. Okay, and number 3, the part of the fraction may be cracked. Okay, and cracking is a process where you can break the long chain hydrocarbon into short chain hydrocarbon. May I repeat again that cracking breaks down molecules into smaller ones. So suppose you have propane that is containing 5 carbon, and you can break it off into an alkane and alkene. That is, you can break it off into C. Let me show you. Suppose you have a compound of C5H12. This is propane. Okay, this is this is pentane, and if you crack it, it might give you C2H4 and C3H8. That means an alkene and an alkane can be produced. That means you are also breaking the pentane into C2H4 and C3H8. That means methane and that is C3H8. Okay, so pentane can be broken into C3H8 and C2H4. That means when you crack a gaseous substance, or when you break a fraction, there must be an alkene and an alkane. That means we have seen when pentane is broken, that means C5H12 is broken, a C2H4 and a C3H8 is formed. That means an alkene and an alkane is formed as well. So how cracking in the carbon in the lab, how cracking is continued or cracking is conducted in the lab, we have to see that. This is the thermal decomposition. We have to say that is thermal decomposition. When this is here, heat is produced, and this is 3 to 4 centimeter depth of mineral wool soaked into an hydrocarbon oil. That means the molecule that is containing carbon and hydrogen. So when they are heated with an aluminium catalyst, you all know about the catalyst. That is the catalyst, a substance that is used to speed up the reaction. Okay, and here the catalyst is aluminium oxide. Okay, so we are heating an hydrocarbon oil to crack it. Okay, and this is the result, a comparison of the reactant and product that give these results. That means we have 4 categories to judge about or to comment on the result. That is appearance, smell, flammability and reactions. Okay, we have to compare about the reactant and the product. Okay, so the appearance of the reaction is thick colorless liquid. That means here, why this is thick colorless liquid? Because the hydrocarbon well which need to be cracked containing more carbon. That means the carbon, when more number of carbon atoms are there, the color becomes thick black, okay, and the product is obviously a colorless gas because you are converting them into alkene and an alkane, okay. So the appearance of the reactant is thick colorless liquid and the product is colorless gas. And let's come on the smell. In the reactant there you'll find no smell, but in the product you'll find a pungent smell. And flammability, that means the ability to catch fire, that is difficult to burn to the reactant, but it means the reactants are difficult to burn. Why they're difficult to burn? Because the hydrocarbon oil or the reactant here containing more carbon, as I have said earlier, and so they're containing more carbon atoms, and containing more carbon atoms also increases the boiling point, okay. So if they're cracked into smaller ones, that means they will burn easily. And the reactions, few chemical reactions and many chemical reactions, because the product which we are getting in a smaller fraction, that means the fractions are also broken into smaller fraction, those have different many reactions, many chemical reactions, because they have different uses. Well, the larger fractions have least uses, and the more smaller fractions have more uses, and that's the main motto of the cracking, that is we use cracking to break down the large chain carbons into smaller chains and to use their productivity and use their feature as well, okay. And the results indicate that the heating has caused the hydrocarbon oil to break down. Thermal decomposition has taken place, okay. So a thermal decomposition means when heat is provided and the compound is broken into two different products, that is a thermal decomposition reaction. That means the reaction that occurs using heat. Okay, you can note these results, that is the reactant had high boiling point and was not flammable, as I have said earlier, which tells us that the large molecules with long chains of carbon atoms. The product has low boiling point and very volatile, so it must have small molecules with short carbon chains, okay. The product must also be a hydrocarbon, since nothing new was added during the reaction, so the molecules of the hydrocarbon will the molecules of the hydrocarbon oil have been cracked, okay. The product must be a hydrocarbon since nothing new has been added to the reactions. That means the product we are getting must be hydrocarbon, because a hydrocarbon oil has been burned, a hydrocarbon fraction has been burned, and a hydrocarbon fraction has been decomposed, so the product must be a hydrocarbon, okay. So the product is more reactive, so could be more useful in this industry, as I've said you earlier, because the smaller fraction have huge number of uses. So to increase the amount of their uses, we use cracking to break down into smaller fractions, okay. Let's move to the next page, that is the cracking in the oil refinery. The cracking in the oil refinery, that is cracking in the oil refinery. In an oil refinery, cracking is carried out in much the same way. The long chain hydrocarbon is heated to vaporize it, and the vapor is usually passed over a hot catalyst. As you have seen, the catalyst is aluminum oxide. Thermal decomposition takes place. Cracking is one of the most important reaction in the oil industry, and so now we'll discuss about the cracking. It lets you turn long chain, the feature of the cracking. Why do we use cracking? Okay, you remember that cracking is a process where the bigger fraction is broken into smaller ones, where the bigger fraction is converted into smaller ones, okay. So it lets you turn long chain molecules into more useful shorter ones. That means when you are breaking the larger chain into shorter ones, it makes it more useful, okay. For example, you may have plenty of naphtha fraction but not enough gasoline. That means the naphtha can be please let me switch you to the other page. That is, you can see here that naphtha and gasoline, naphtha is lower than the gasoline. That means it contains more carbon atoms. That means when you break naphtha, it can produce gasoline as well, okay. So here so you could crack some naphtha to get molecules of the right size of petrol. Okay, you know that gasoline is used to produce petrol. Okay, the number 2, that is, it always produces short chain compounds. It always produces short chain compounds that have a double bond, and which contain double bond. That is, an alkene contains a double bond. These compounds reactive. These compounds makes it more reactive. That means alkane doesn't have that much reactivity, where the alkenes have more reactions. That means it has a more reactive power than the alkane. Okay, so they can be used to make plastics and other substances. That means an alkene can be used to produce different fractions. Okay, now let's see the example of cracking the naphtha fraction. This kind of reaction takes place when you crack naphtha. Okay, naphtha, that means Dakin C10H22 from naphtha fraction, and this is the temperature needed, that is 540 degrees Celsius. That means a huge temperature is needed. A catalyst must be present there, and this is an alkane product, that is naphtha fraction. It will contain 10 carbon with 22 hydrogen. Okay, and the side carbon will contain 3 hydrogen, and the mid carbon will contain a maximum number of 2 hydrogen. Okay, they can be broken into some part, that means 3 product. That means it has been produced to make pentane, propene and ethene. That means you have seen, as I have told you earlier, that is, when you are conducting a cracking, the product will have alkane and an alkene. Okay, alkene is a must product. Alkene is a must product in the cracking. That is, pentane C5H12 is suitable for petrol and is also producing 2 alkene product, that is propene and ethene. Okay, so let's see, the Dakin has been broken down into smaller molecules. Look at the propane and ethane molecules. They have carbon-carbon double bonds. They are called alkenes. That means how you'll identify an alkene or an alkyl. Alkane always contain, that is, carbon-carbon single bond. That means no double bond will be present in alkane group. And alkene group there will always be a double bond, that is 2 alkene products. These are 2 alkene products that have a carbon-carbon double bond between them. Okay, and cracking ethane, that is, how will you cracking ethane? That is, when ethane is a alkane, and if you crack it, it will form ethene and hydrogen. You can have a question here, why no alkane has been produced here? Yes, no alkane has been produced here because I have told you that alkene is a must product in a cracking. Cracking, so alkene must be produced here, and here alkene means C2H4. So if you give here containing C2H6, and if it produces C2H4, 2 hydrogen atoms are being remained, so it will convert them into hydrogen. Okay, so let's see the conclusion, that is, ethane is already a small molecules, so even small molecules can be cracked. The hydrogen produced may be used to make ammonia. Okay, the hydrogen produced may be used to make ammonia. Okay, the hydrogen here is used for making ammonia in the industry. So ethane is already a small molecule, so even a small molecule can be cracked. That is, the simplest molecule, that is ethene, is produced here. I hope you are clear with the topic, and if you have any confusion, let me know on the comment section. Okay,